So here's the solution for number 13. You start with this problem, and when you set up a u-substitution, I set it up with x minus 2 as my inside function, which is right here, x minus 2. The derivative is 1 dx. The problem with that is that that doesn't actually help us to substitute in for this x plus 2. So when our u does not actually take care of or replace all of the x's in the equation, what you would do in that instance is you would rewrite u in terms of x. So to solve this to be x, I would just get rid of this minus 2 by moving it over to the left-hand side and adding 2. So this becomes x is equal to u plus 2, and I've written that right here. So this x minus 2 is taken care of here with the u, hence I replaced that there. This x plus 2, I can't take care of that necessarily with my u, but now I know how to rewrite x in terms of u. So I can rewrite that as u plus 2. So this x gets replaced with u plus 2, and then this plus 2 stays here in this problem. So it becomes u plus 2 for x, and then plus 2, just as you see it here. Combine like terms to get u plus 4. Distribute this square root of u into both of those. Remember that the square root of u is the same thing as u to the 1/2. So when I add the u to the 1/2 and the u to the 1, or sorry, when I multiply them, I add their exponents. So I get u to the 1 plus 1/2. Then we have 4, and then when I distribute the square root of u there, I have 4u to the 1/2. Integrate, I added 1 plus 1/2 to get 3 halves there. Integrate both sides, so that becomes a 5 halves, that becomes a 3 halves, and we have our 2/3 and 2/5 plus c. Rewrite it in simpler terms, and then just replace u with what it equals again.